Today I am going to discuss about capacitance. It is a very important device which is used either in electrical circuit or in electronic circuit. It's a very important device. But before that, let me tell you about something about conductors and dielectrics. When a conductor is placed in an external electric field, due to the free electrons present on the surface of the conductor, an electric field is induced in a direction opposite to that of the applied electric field. Now, in case of a dielectric, let us consider polar molecules. The polar molecules, it has a permanent dipole moment. But in the absence of an external magnetic field, they are randomly distributed, so your net dipole moment is 0. When it is placed in an external electric field, the dipole moment aligns itself in the direction of the external electric field. Your net charge is 0, but there is a net dipole moment. So what happens here, that as the dipole, when it is placed in an external electric field, as the dipole arranges itself in the direction of the external electric field, a charge density is developed on the either faces of the dielectric, which is perpendicular to the electric field. On the one side there is a negative charge density, and on the other side there is a positive charge density, and because of it an electric field is induced. So what I want to tell you, that when a conductor is placed in an electric field, the induced electric field in the conductor is due to the free electrons on the surface of the conductor. But in case of the dipole, the electric field is produced due to the formation of charge density on the either faces of the dielectric, which is perpendicular to the electric field, and the dipole is aligns itself in the direction of the external electric field, where the net charge is 0, but there is a dipole moment. So now let us come to the capacitance. Why I have taken capacitance? Because in capacitance we are going to use a dielectric. So what happens in a capacitance? It consists of two plates, and when an external potential difference is applied, charges are developed, equal and opposite charges are developed on the plates of the conductor, and an electric field is developed between the conductor and the charge. This electric field is proportional to the charge developed. If the electric field is double, that means the charge developed must be double. So here we see that a capacitor, it's a parallel plate with a vacuum in between the plates, and when it is connected to a potential difference, then charges are developed, equal and opposite charges are developed on the parallel plates, and there is an electric field in between the plates, and this electric field is proportional to the charge developed. So this is a capacitor. So what is the importance of a capacitor is that the electric field outside the plates on both sides outside the plate is zero. Why zero? This can be explained by the help of Gauss law, because on outside the surface electric field will be produced by both the positive and the negative charge, and the electric field will be in opposite directions, and so they will cancel out. That is, we know that from Gauss law, we know that electric field due to an infinitely charged sheet is sigma by 2 epsilon naught. So a capacitor here, this is a parallel, the two parallel plates conductor with positive charge on one conductor and negative charge on another conductor. But remember that the charge are of equal magnitude, but they are in opposite sign. If you consider outside the plate any point, due to the positive charge due to the positive charge sheet, electric field will be produced, that is sigma by 2 epsilon naught, and because of the negative charge again electric field will be produced sigma by 2 epsilon naught, but since they are in opposite directions, so they cancels out. Similarly will be the case on the other surface of the plate. But inside the plate, that is inside the capacitor, electric field is at any point an electric field is developed, and here the electric field produced by the positive plate and the electric field produced by the negative plate are in the same direction, so they adds up, and so it becomes sigma by 2 epsilon naught plus sigma by 2 epsilon naught, that is equal to sigma by epsilon naught. Now here we see that a parallel plate capacitor, here we find that a parallel plate capacitor, charges are developed, equal and opposite charges are developed on the plates. At the same time there is an electric field between the plates. So you see that a capacitor, it can hold charge. A capacitor, it can hold charge. So here the capacitance of a capacitor is equal to Q by V. That is, from this formula we come to know that even a low potential difference capacitor can hold. It has a high capacitance, that means it can hold charge, higher amount of charge. So here we find that a capacitor, it can hold charge. Let me tell you one thing, that if how you take up two parallel plates and in between the plates it's vacuum, when you connect to a potential difference, that means you are connecting to a potential difference, that means either you are connecting to some source, it may be a battery. When you connect it, then opposite charges are developed on the either side, or equal and opposite charges are developed on the plates, and when you remove the battery, the charge remains equal and opposite charge. You can say that you can say one thing, that when two parallel plates capacitor, when two parallel plates capacitor is connected to a potential difference, that is a battery, then equal and opposite charges are developed on the plates and an electric field is developed in between the plates, and this electric field is proportional to the charge developed, and the capacitance of a capacitor is equal to Q by V, and from here we come to know that even for low potential difference it has a high capacitance. That means it can hold charge. So this is a very important device. It is a device that can hold charge. It's a device that can hold charge. So when it can hold charge, that means there is some energy, that is there is some potential energy. So it becomes a source. It becomes a source. Now, if we increase the potential difference, then there is a probability that the air around the plates may get ionized, and as it gets ionized, the charge developed on the plates, it will move and gets neutralized. So we do not increase the potential difference between, we keep it to a certain limit such that the air outside the capacitor does not get ionized. So here you find that it is a device which can hold charge, and the capacitance of a capacitor is epsilon A by D. A is the area of the plate and D is the distance between the two plates, and its units is farad. So we find that it is a source, it becomes a source of energy. Now, so it is used either in electrical circuit or in electronic circuit. If there is a fall in the current, then this capacitor works as a source of energy and maintains the steady flow of the current. And it is actually fitted with the power source. It is actually fitted with the power source. So here, what we conclude here is that a capacitor, it can hold energy, and at the same time there is an electric field in between the plates, and the electric field is proportional to the charge developed on the plates. Now, if we place a dielectric medium in between the plates, what happens that the capacitance of the capacitor increases. It increases by K times, which is called as the dielectric constant. K is called the dielectric constant. Now here again there is a difference between a conductor and a dielectric. When a conductor is placed inside an external electric field, an electric field is developed in the conductor, that is on the surface of the conductor, and this electric field is in a direction opposite to the external electric field, and this internal electric field increases until it becomes equal to the external electric field. So here your net electric field is 0. But in case of dielectric, the net electric field is not zero. And when we introduced a dielectric,